All right. So this is 2017 number 5. Word of warning: this one is part of the stuff that got cut out at the end of the year. Um, so this one, like this, won't be on the AP test, but it's still good to see. So the table and bar chart below summarize the age diagnosis in years for a random sample of 207 men and women currently being treated for schizophrenia. Do the data provide convincing statistical evidence of an association between age group and gender in the diagnosis of schizophrenia? All right, so a couple things. Like we're doing an inference procedure here. It's asking, is there evidence? It's just an inference procedure we haven't learned yet because the data. All right, so we have categorical data, right? We have men or women, and we have them dumped into some age groups, right? So we have categories across and categories up and down. If we only had 2 of each category, this would be a 2 proportion z-test. We do not just have 2 categories. We have men and women, but we have 4 different age groups. And sure, you could probably lump them together and see if turn it into that. But when you have multiple categories, what you're really doing is we are going to do what's called a chi-squared test. This is going to be done, honestly, primarily on the calculator because, yeah. But you still have all the same steps of hypothesis testing and whatnot, namely hypotheses. All right. So our hypotheses are a little different. Our null hypothesis is going to be that gender and age are independent, and age are independent. Our alternative hypothesis is going to be that they are not. What this lets us do is then we kind of figure out what, if they were independent, what should our data look like, and then do some calculations on top of there that you're not going to do. But these are our hypotheses, our model. So we still do have to check some conditions. The first one is that they're random. This is a random sample of 207 men and women. The second is that we expect 5 people in each bucket. Expected. We don't know this yet. All we have right now are the actual counts. These are the actual counts. Our expected counts are going to come during the process. And let's show you where. All right. So the way this works on the calculator is first, we turn the calculator on. Second, we go into matrix. Edit matrix. 2x4. So this is a 2x4 matrix, right? We have 2 and we have 4. So we'll type that data in there. So these are our actual counts. Then, when we go to do, actually, let's make sure I'm out of there. Stat, tests, chi-squared is very much toward the bottom. That's a chi. It's like an X, but fancy looking. Chi-squared, observed. So this is what we saw. Expected. We do not have to put anything in there. That's where we want to output it. And then calculate. All right. So we're going to skip a bit because we have some more stuff for our next part. This is the mechanics. All right. So we've got 3 degrees of freedom. Our chi-squared was 10.884, and our p-value was 0.01237. Right, that's all of that stuff. P is the p-value, and that's a p-value that we will interpret exactly the same as we would interpret a p-value before. It's less than 0.05, we have strong evidence, yada, yada, yada. We'll get there in a second. Let's go back to expected. So, under matrix, let's look at matrix B. These are the expected. If they were independent and we had 99 people between 20 and 29, 63 people between 30 and 39, 119 women, 88 men, all of that stuff, and they were independent, this is how the data would have to shake out. We'd have 57 women between 20 and 29. We'd have 42 men between 20 and 29. We'd have 36 women between 30 and 39 and 28 men between 30 and 39. We'd have 17 women between 40 and 49 and 13 men between 40 and 49. We'd have 9 women between 50 and 59 and 6 men between 50 and 59. So like just kind of looking at that, it seems like men are more likely to be diagnosed when they're young, between 20 and 29. Women are less likely to be diagnosed when they're young. They're more likely to be diagnosed older. For whatever reason. I don't know anything about schizophrenia. Maybe it appears at different times in your lifespan, or it's just easier to tell. I don't know. But our expected values are all greater than 5. So we might actually want to write this down. Expected 57, 42. I gotta get up to the calculator again. 36, 27, 17, 13, 9, and 6. Are all greater than 5. Yeah, so that's that. And then the conclusion. With a p-value equal to 0.01237, which is greater than 0.05, which, is less than 0.05, we reject the null hypothesis. We have strong evidence, or have evidence, that there's an association between gender and age at diagnosis of schizophrenia.